Hello, everybody. So this is our first unit in the physics class, and you will be learning about kinematics. And so your title is going to be kinematics. What are kinematics? The kinematics is the science that will describe motion. So in other words, in this unit, we will be learning about. So let's write this down. Kinematics is the science of describing the motion of objects using words, diagrams, numbers, graphs, and equations. So in this unit, we will be learning about, we all have heard of the word motion, and we know that means this is something that is moving. So when things are moving, there's a change in distance or displacement, or of course there will be speed, velocity, and acceleration. And for these, we will use the terms of some of them will be scalar, some of them will be vectors, and we will talk about this in more depth. But whenever we want to prove something in the physics class, you will always have to use CERs. So CER, which is the claim, evidence, reasoning, is what you need in the physics class to prove whatever concept or content you have. So before we get into the CERs, let's talk a little bit about scalars and vectors. So as we said that when we talk about motion, this is something that is moving. When things are moving, they of course have velocity or speed. They have a distance that they went through, right? So that distance can be either a scalar or it can be a vector. What is the difference between a scalar and a vector? So let's start by saying that when we talk about scalars, so let's say I was driving 25 miles per hour, or I was driving 25 miles per hour east of Janet Street. Just the first sentence saying I was driving 25 miles per hour, that is by itself a scalar, because it's a quantity that was described by a magnitude. While as when I say I drove 25 miles per hour east of Janet Road or Street, I'm giving you a direction and a magnitude. Then now I am talking about a vector. So let's write this down. Scalars are quantities that are fully described by the magnitude or the number value alone. While as vectors are quantities that are fully described by both a magnitude and a direction. All right, we're gonna work on a few examples. So for example, I'm gonna give you the quantity and you have to try to figure out the category. So here I got the quantity. Let's do example. So we got quantity here and we got the category here. So when you're given, I'm going to write them all down first and then probably going to take a minute to think about them and then I'll go back to them. So 5 meters, 30 meters per second east, 5 miles north, 20 degrees Celsius, 4,000 calories. All right, so let's see what does each one of them represent. So when we're talking about 5 meters, I know this is a scalar because it only represents a quantity, a value, a number, a magnitude. It does not give me no directions. 30 miles per second, that would be a vector. Per east. So this is a vector because it's showing me it's east. 5 miles north. Again, I have north. That's given me a vector. So here, let's write this because there is a direction here. Scalar because no direction. Vector because I have a direction. Celsius is a scalar. And the reason why, because there is no direction. 4,000 calories. That is also a scalar because I got no direction as well. All right, so this is the two different forms of quantities that might describe your distance or your displacement. And we're going to talk about this in more depth. All right, so when we talk about distance and we talk about displacement, what is the difference between a distance and a displacement? So the distance, if you think about it, I am traveling from here to my house, and that would get me, 2 miles. The 2 miles, I'm talking about a distance, okay? So when I say 2 miles and distance, I automatically know that I am talking about a scalar. But let's say, for example, I'm saying I'm going to drive 2 miles from here to my house. I'm going to take South Gully Road. South Gully Road, now I'm talking about a displacement because, and I'm going to go from here, turn to Michigan Avenue, make a U-turn on Michigan Avenue, and go South Gully. All these places that I wanted to get to my house, that would give me the displacement. All right. Let's write this down. So how do we define distance? So distance is a scalar quantity that refers to how much ground an object has covered during its motion. Okay, so we're talking about how much it has covered during the motion. So that's distance. It's very important that you know the difference between the distance and the displacement. And there will be, of course, an assignment on Twig and a worksheet for you to explore. Now, what is a displacement? Displacement is a vector quantity that refers to how far out of place an object is. So in other words, it's the overall change in position. So it's the change in position because there will be direction and there will be magnitude as well. All right. So let's have an example. So let's do example. So I have, let's see. When time was 0, there was, I'm not good at drawing, but I'm going to do my best. But this guy here, when the time was 0, and then he was in position A, and then when the time was 2 minutes, that was the guy's position C. Well, let me say here he traveled 40 meters, and then he traveled 100 meters, and at time t equal 3, was in position D. But first, he moved from here all the way to that position in 1 minute. So that was time equal 1 minute, and that was position B. So I know I did not do them in order for you, but just so that you can copy this diagram. All right, so what was the final position? So we knew that it went from time 0 to 1 minute, of course. That would go before the 2 minutes or the 3 minutes. So for him to go from time 0 to 1 minute, he traveled 40 plus 100 plus 40, right? That was the distance traveled. And then we noticed that there was a U-turn that moved him in the opposite direction. So he got to that 2 minute. And then he went straight to the same position, or not position, I'm sorry, direction to get to that 3 minute. So how do we find which one is the distance, which one is the displacement? So let's find this out. So when we talk about distance, all right, so distance, that means we do not care about the direction. So the distance traveled, let's see, he got 40 plus that 100 plus that 40 plus he came back to C. So that would be 40 plus 100. And then he traveled again from C to D. And the time here, I'm sorry, the distance here is 100. So that means the distance traveled is, you just add them up, and you will get 420 meters, because the unit is meters. Okay, I hope that makes sense. Now let's see how to find the displacement. So the displacement, we care about the direction. So it went 40 plus 100 plus 40, and then it went in the opposite direction, so which means minus 40 minus 100, because 40 and 100, and then it went again in that direction, which would be plus 100. So now the displacement is, I'm just going to do your math, 40 and negative 40 crossed out. That's minus 100 and 100. So I'm going to have 140 meters. Why? It's because we care about the direction and the magnitude of the object and the displacement. So let's do example 1 here. All right, I'm going to give you another example. So let's do example 2. The question is, what is the displacement of the cross-country team if they begin at school run 10 miles and finish back at school? So, I always suggest and I encourage you to always sketch it or draw a small diagram. So I got that team right here, however you want to pronounce your team or show your team. That is the team in that bubble. That team went from the school 10 miles And then they went back to school 10 miles. So in other words, it was a round trip, right? Okay. So when they went, what is the displacement? Now I know I'm going to have a displacement. The question is about displacement. Is 10 miles, and that's going back in the opposite direction, which would be minus 10, which is 0. Now, what if I ask about the distance? For the distance, we don't care about the direction. All what are you going to say? You're going to say it traveled 10 plus that 10 going the other way, which will make it 20 miles of the total trip, because it really doesn't affect me what direction they're going when we're actually looking for distance. We only care about the direction, the magnitude, when we are talking about displacement. Right? The next lesson will be about speed and velocity.